Um, in the previous topic, I discussed about a particle. So sa particle, even though ang considered sa problem is a body with dimensions, but then particle man ang analysis, so ang size and shape sa body dili mag-matter. So as a result, the forces will be concurrent. Considered siya or assume siya to that the forces will meet at a common point. Okay. Now this time, rigid bodies na. So we will now consider the size and shape of the body. And as a result, it's no longer concurrent. So non-concurrent system na siya. Okay. So two things to consider. One, finding the resultant. And second is equilibrium. So for this one, resultant. Ang tawag is equivalent system of forces. Meaning to say, we have an original system and then we try to create a new system, okay? A new system which is equivalent to the original system or new system but having the same effect as the original system. Yan ang resultant, di ba? So kung sa particle ta, like we have two forces, i-replace na to be a single force resultant but having the same effect. Kato sa parallelogram law. Ana. Okay? So, let's start. In the preceding chapter, it was assumed that each of the bodies considered could be treated as a single particle. Such a view, however, is not always possible. And a body in general should be treated as a combination of a large number of particles. So in this topic, you will study the effect of forces exerted on a rigid body. And you will learn how to replace a given system of forces by a simpler equivalent system. Okay, let us know the external and internal forces. Forces acting on rigid bodies can be separated into two groups: external forces and internal forces. The external forces represent the action of other bodies on the rigid body under consideration. External na. So, mag-consider ka o one body. Okay. So, tanan forces nga naka-connect ato, nag-act ato, are external forces. Okay. Applied loads, external mo na siya, no? Reaction support, external kaya po ng reaction support. Kay dili man naman itong rigid body. Di ba? So, external lang reaction na. The internal forces are the forces which hold together the particles forming the rigid body. So, later nga, applications sa rigid bodies, you will learn what internal forces are. Okay. So, an example of external forces, let us consider the forces acting on a disabled truck that three people are pulling forward by means of a rope attached to the front bumper. Bene. No. So, gibira siya. The external forces acting on the truck are shown in a free body diagram in figure 3.2. Kana. Moni ang external forces. Okay. Force exerted by the road surface tires, ang tension sa cable, okay, ang amount of force exerted by the three people, ang weight dayon. Ang weight is considered external. So, for this topic, it is important for you to know about the principle of transmissibility. Unsa man principle of transmissibility. So, the principle of transmissibility states that the conditions of equilibrium or motion of a rigid body will remain unchanged if a force acting at a given point of the rigid body is replaced by a force F prime. Kini no? Na kay force nga nag-act dire. Karon, at a different point along the same line of action dire, na kay force F prime. Pero same magnitude, same direction pod. First quadrant, sana. So same magnitude, same direction, but acting at a different point. Kini siya. Provided that the two forces have the same line of action. Kining dotted lines, mao ning line of action. So kung inani ang condition, pasabutan mo niya mahitabo. Mo niya ang principle of transmissibility. The condition of equilibrium or motion of a rigid body will remain unchanged. Pasabot na kini siya is the same as this. Or practical na pag-explain, ang force di ay pwede nimo siya ibalhin-balhin bisan asa for as long as same yung magnitude, same direction, same line of action. So kung ibalhin mo ni F dire, pwede. Basta kay first quadrant. Dire, pwede po. Diha, pwede sa bisan asa. Basta same line of action. Pero kung i-transfer ni mo ng F, dire na point, dili na. Lahi na siya nga condition. Okay? So, mao niya ang principle of transmissibility. Same rin na sa weight ba? Weight vertical. Pwede mo ibutang dire, pwede sa ibabaw, pwede sa nasa. For as long as same line of action. So, inana ang principle of transmissibility. The two forces F and F prime have the same effect on the rigid body and are said to be equivalent. This principle, which states that the action of a force may be transmitted along its line of action, is based on experimental evidence. Experimental evidence. So it cannot be derived from the properties established so far in this text and must therefore be accepted as an experimental law. So this is based on experimental evidence. Okay. So part of this topic involves vector product of two vectors. So let us first review about vector product of two vectors. Okay. The vector product of two vectors P and Q is defined as the vector V, which satisfies the following conditions. Number one, okay, the line of action of V is perpendicular to the plane containing P and Q. So, suppose kining parallelogram, this is the plane containing P and Q. Okay. The line of action of V daw is perpendicular sa plane. So, for example, kuha ni siya, floor. Okay? Floor. Vertical ni siya, horizontal man eh. So, vertical. So, perpendicular iyang line of action. Sa pasabot sa one, line of action, pwede sa upward, pwede downward. Kaya line of action man. Okay? Muna siya ang sa condition number one. Number two, the magnitude of V kay vector man. So nasa magnitude, not such a direction. The magnitude of V is the product of the magnitudes of P and Q and of the sine of the angle theta formed by P and Q, the measure of which will always be 180 degrees or less. We thus have this one, V equals PQ sine theta. Magnitude lang niya, magnitude lang. The third condition is this one, the direction. Line of action is different sa direction. So, kung may vertical line, mo na yung line of action. Pero ang direction, it could be upward or downward. Okay, so dili sila pareha. The direction of V is obtained from the right hand rule. Kini. Mao man siya, mo na upward siya diri kay this is the result of the right hand rule. So, in doing the right hand rule, close your right hand and hold it so that your fingers are curled in the same sense as the rotation through theta, which brings, take note, rotation through theta, which brings the vector P in line with the vector Q. Sa ato pa, ang P, i-rotate ni mo ning P para mo coincide sa Q. Rotate ang P, mo coincide sa Q, mo na imong V na yun. Your thumb will indicate the direction of the vector V. So, if you're familiar with the right hand rule, anisa, your four fingers, this one, kaning four fingers nimo, will point to the first vector. Ang thumb will point to the second vector. So, nadiring four fingers, nadi ang thumb. I-rotate ni mo four fingers para mo coincide sa thumb, pina-curl gamay. Okay? Curl do. Your fingers are curled in the same sense as the rotation through theta. So, pag curl sa four fingers para mo coincide sa thumb, mo na yung position sa imong right hand. So, the thumb points to the direction of V then. Mo na siya ang right hand rule. Okay. Now, instead of the right hand rule, ma-confuse ka or kining, you'll find it difficult using the right hand rule. Na ay alternate na way ana niya. Okay. Using kining unit vectors. Vector products expressed in terms of rectangular components. So let us now determine the vector product of any two of the unit vectors I, J, and K. Considering first the product I cross J, kini figure A, I cross J, since both vectors have a magnitude equal to 1, and since they are at a right angle to each other, their vector product will always be a unit vector. This unit vector must be K, since the vectors I, J, and K are mutually perpendicular and form a right-handed triad. Now, if we go back to the right-hand rule, I cross J man. So the first vector is I. Nadire imong four fingers. Nadire imong thumb sa J. So i-rotate ni mga four fingers, mo coincide sa J, i-curl gamay, mo ni ang direction sa imong thumb. Kung gusto ka mo try yan you can try this one. Four fingers, thumb, i-rotate ni mo, i-curl gamay, ang result na diri mo thumb. Mo ni ang direction sa unit sa vector product. For this one, on the other hand, it follows from the right-hand rule that pag J cross I, first vector, nadiring four fingers, nadiri ang thumb. Pag curl gamay, na dito ang thumb. Pahingon. So, you can try also this one. Four fingers dire, and then thumb, curl gamay, and then nadiri ang direction sa thumb. So, nadiri ang vector product. So, if you find this one difficult, na alternate na way yan niya. And finally, it should be observed that the vector product of a unit vector with itself, such as I cross I, is equal to 0 since both vectors have the same direction. So, dili ka pwede mo gamit sa right-hand rule ani kay same man siya unit vector. So, walay ma-curl, dili ka pwede mag-curl kay ang 4 fingers ug ang thumb same man sila og direction kay I cross I. No? The vector products of the various possible pairs of unit vectors are this one. Because kung mag-perform ka cross product, V, bariya niyo. Like V equals P cross Q, ba? Okay. V equals P cross Q. Katong P nga vector nimo, namo to si components Pxi plus Pyj plus Pzk. Ang Q sad, asad kay Qxi, Qyj, Qzk. So pag perform nimo cross product, P cross product Q, mag-involve siya og cross product sa unit vectors, I cross I cross J, I cross K. Ba? Mao ni siya ang vector product. Okay, as discussed a while ago, same unit vector 0, ang cross product, J cross K 0, K cross K 0. And then the rest, result ni siya sa right-hand rule. I cross J, K, I cross K, negative J. Using right-hand rule. Okay? Pero kung dili ka sold out sa right-hand rule, mao ni ang sign convention. By arranging in a circle and in counterclockwise order, the three letters representing the unit vectors, figure 311, kini, arranging in a circle daw and in a counterclockwise order, I, J, K. We can simplify the determination of the sign of the vector product of two unit vectors. Okay. Mo ni siya ang simplification or interpretation. The product of two unit vectors will be positive if they follow each other in counterclockwise order, and will be negative if they follow each other in clockwise order. Okay. Hint. Hint same unit vector 0. The rest, present yun tulo ka unit vectors, I, J, K. Oh, it's not possible na I cross J is J or I cross J is I. K, na siya. So, I, J, K. I og K, so na kay J. J and I, so K. J and K, so na kay I. K and I, so J. K and J, na kay I. So, no question about it. Okay. Dapat naagi na present din ang tulo ka unit vectors. So, ang problema na to is ang sign. When is it negative and when is it positive? Okay. Oh. Kano saan mag-positive ang vector product, kano saan mag-negative ang vector product? Muna ang answer na pag mo follow siya in a counterclockwise order, positive siya. Parehan eh. IJK. Counterclockwise mo na IJK. Counterclockwise. Positive siya. This one, IKJ. Ano na IKJ. Clockwise siya. IKJ. Clockwise siya. Therefore, negative siya. You can do the same sa other na vector product. JKI, oh. JKI. Counterclockwise, positive. Okay, so instead of memorizing this one, you can use this technique. Buhat ka og kini circular arc and then put IJK. Okay. Ako sad, I myself, nasad ko yung own technique. Okay. Sige na. Later na. Okay. We can now easily express the vector product V of two given vectors P and Q in terms of the rectangular components of these vectors. So resolving P and Q into components, we write this one. Pxi. So perform cross product, and then supposed to be 3 times 3, ano, 9 terms. 9 terms, ha? Pero kay ang I cross I kay 0 man. J cross J 0, K cross K 0. So from 9 terms, kay 3 man, 3 times 3, 9. From 9 terms, 6 na lang. So sa 6 terms, ang duha ka terms na I, duha ka terms J, duha ka terms K. So i-combine nimo to para ang result niya vector product na IJK yapon. Component sa vector V ang result. I-combine na nimo tong duha ka terms na I, duha ka terms na J, duha ka terms na K. Okay. Now, I have my own way of getting the vector product. Okay. Instead na kini circular, I'm using lines. Okay, so IJK ko, IJK. Okay. To the right, IJK. And then, kopyahon ako ang IJ. Ayaw na ng K, so IJ. Ano na yun? To the right is positive. To the left is negative. Meaning, kung mo-follow siya in a, mo-follow sa direction na going to the right, positive siya. Going to the left, negative. Like this one. IJK. IJK. Right man eh. IJK. Positive siya. Kini, IKJ. IKJ. Left man siya. IKJ. Going to the left, negative siya. JIK. JIK. Left man eh, negative siya. JKI. JKI. Right man, positive siya. Mao na akong style. Eh? Mao na akong sign convention. Okay. Kung gusto ka kaning circular, okay ra. No problem. You want to memorize one, okay ra gyapon. No problem. If you want to use my style, okay ra gyapon. Okay. So kung asa convenient magamit, didto ka. No problem. Okay. This is an example of a vector product, kining moment. Okay. Moment of a force about a point. Okay. Let us now consider a force F, force F, acting on a rigid body. Rigid body ni. The position of A can be conveniently defined by the vector R. So, bali ang R is vector na siya starting from O and mo-end siya sa A. Okay. Ang A sad, dili nag-act imong F. So the position of A can be conveniently defined by the vector R, which joins the fixed reference point O with A. Okay. This vector is known as the position vector of A. Muna yung R, position vector. Okay. We will define the moment of F about O as the vector product of R and F. Kana. Nga naman. Okay. Inane sa. You look at this figure. Maumuni mong R, di ba? Tapos mo ni mong F. And if you will extend the line of action of R, the angle between R and F is theta. Now, by principle of transmissibility, we can transfer R sa A. So, nadiring R, oh. Principle of transmissibility. And get the vector product, R cross F sa kay. Ang R, ang first vector, di naman mo point ang 4 fingers sa first vector R. I-rotate ni mo para mo coincide sa F. Mao na siyang R cross F. Ang thumb dayon ni mo, dili mo point. Na din ang moment niya. Mao ni ang direction sa vector product, which is M. Okay, mura man siya og P cross Q equals V. This is the vector product. Ang direction niya is upward. Okay. Mo man imong first vector R. 4 fingers, thumb. Pag curl sa 4 fingers, mo na niyang thumb na yun. Kini. Upward. So, mo follow siya ni. R cross F. Dili sa F cross R, kundi R cross F. Okay. Kung mag-F cross R ka, F cross R, ang direction sa M ni mo is downward. Now, denoting by theta, the angle between the lines, a line of actions or the position vector R and the force F, we find that the magnitude of the moment of F about, magnitude ha, katong second condition sa vector product, na the magnitude is this one. RF sine of theta. Okay? RF sine theta mo na ang magnitude. Ato din gi-replace og FD because okay, if you will extend the line of action of F, this one, and denote this one D, perpendicular distance of F 2.0. Naman din yung F, di ba? Get the perpendicular distance of F 2.0 denoted by D. If this is theta, theta man sad ni. So from trigonometry, sine of theta is D over R. Or simply, D equals R sine theta. So, ang R sine theta dire, i-replace na to og D. Mao na siya nga ang moment is equal to force times perpendicular distance. Na ang moment. Okay? So, for problems involving only two dimensional structures and the forces acting on them can be readily represented on a sheet of paper or on a blackboard. Their analysis is simpler than that of three-dimensional structures and forces. So, consider, for example, a rigid slab acted upon by a force F. Okay, mao ni siya, force na perpendicular distance D. Same na silang moment, pero ang direction nila lahi. Same F niya, same distance. Okay. Ang moment ani is counterclockwise. Positive siya, counterclockwise. While ang moment ani is clockwise. Obvious man kay diri mo ka rotate sa O. So, ang motion niya paano siya? Clockwise, di ba? This one, counterclockwise. So, mo rotate ka sa O, paano mo F? That's counterclockwise. So the moment of F about a point O chosen in the plane of the figure is represented by a vector M sub O perpendicular to that plane and of magnitude F times D. Okay. We can observe in the first case that F tends to rotate the slab counterclockwise, and in the second case that it tends to rotate the slab clockwise. Okay. Rectangular components of the moment of a force. The determination of the moment of a force in space will be considerably simplified if the force and the position vector of its point of application are resolved into rectangular X, Y, and Z components. Kung mangita ka og rectangular components of a moment of a force sa 3D, dapat naka-IJ kaya X, Y, Z components no? Para mas dali mag-perform og cross product. So for example, the moment M about O of a force F, whose components are Fx, Fy, and then Fz. is applied at the point, kini nga point, ay coordinates pod x, y, ug z. Diba? O, kaniyo? R, x, y, and then z. So observing that the components and the position vector are respectively equal to the coordinates x, y, z of the point A, we write, mo na itong R, tas mo na itong F. And then perform din ka o cross product. We write the moment M sub O F about O in the form. Mo na ni ang result. Pag perform nimo sa cross product R cross F, as I've explained a while ago, pag perform sa cross product R cross F, instead of 9 terms, 6 na lang, kaya ang I cross I 0, as well as J cross J and K cross K. So, out of the 6 terms, 2 ka terms ana is I. Mo na ni siya, MXI. 2 terms J, MY, 2 terms combined, that's MZ. So, mo na ni ang component sa moment. Rectangular component sa moment. Kung 3D okay. Sample problem. Okay. A 300 Newton force is applied at A as shown. This one. Determine the moment of the 300 Newton force about D. Okay. And then letter B, the smallest force applied at B that creates the same moment at D. Now, kining sa letter A, determine the moment of the 300 Newton force at D. Sometimes, ang lisod diris ang pagkuha sa perpendicular distance lisod siya. Oh, ngayon ka, the moment is F time din na F. Ang D na lang ang problema. O diha man ang lisod. So ang pagkuha sa perpendicular distance. So kung inclined ang imong force, na-angle siya from the horizontal or vertical, ang imong perpendicular distance inclined pod. So diha ang lisod. So as an advice or a suggestion, ang buhaton nimo is you resolve the force into x and y components. Mas dali siya. Okay? So ang solusyon niya kung i-present dire is sa for letter A is i-resolve siya into x and y components. Ang force kana 300 cosine 25 this one, and then vertical component 300 sine 25 this one. Now, unsay purpose nga nani? Mas dali man siya because if a force is horizontal, ang yung perpendicular nga ang perpendicular sa horizontal is vertical man. Na given man itong mga vertical distances and horizontal distances. Same also, pag ang force is vertical, ang yung perpendicular ana is horizontal. Diba? So, dili ka maglisod pagkuha sa distance. Okay. Now, kung maglibog yapon ka, what's the perpendicular distance of this force about D? Di ba? Layo man. You can use principle of transmissibility. Imo ni i-translate dire patungod nimo sa D. Okay? Okay. Mo ni atong kuan na sign convention counterclockwise, positive, clockwise, negative. Okay. So, mo ni siya ato sing ipaduol para kuan. Pwede na siya by principle of transmissibility. Kini siya is equivalent to this one. Nadentay D diha. O di dali ra, di ba? Mo ni itong force which is 271.89 mo din itong perpendicular distance. Oh. Dili ka maglisod. Kaysa kini nga force tapos kuha ni mo ni perpendicular distance. You might get confused. So kini na lang. Sige. Mo ni itong M1. Okay? Kay duha man sila. Ang M1 na to is force 271.89, distance 200 millimeters or 0.2 meters. Ang unit nila yon is Newton meter na. Newton man Tapos meter nila. Kana positive sa kay counterclockwise ni, oh. Ang direction mo rotate sa D ba? So ang movement ani is paano siya? Mo form ko circle ba? Oh, di ba? Counterclockwise. Now, you do the same sa vertical. So, by principle of transmissibility, pwede mo i-project sa taas. Ipa-move nimo, i-translate ba? I-translate. Pwede ra. Kaya naka-state mo sa principle of transmissibility nga, ang condition daw sa equilibrium, dili ma-change. Kung ang force, i-transfer nimo to another point, provided na same line of action dire. So, mo din mo perpendicular distance kana which is 100. And kung mo siya i-rotate about the mo-form ko circle, clockwise siya, di ba? Clockwise. So, negative siya. Force distance of 0.1. Oh. I-add mo na siya ang movement gina ni. Mo na answer niya. Moment about the 41.7. Sorry. This is Newton. Okay. Newton meter. Positive man, so it means counterclockwise. Dako man na 54 kasi 12. Diba? So it's counterclockwise. Pwede na siya. Instead na use this force and then you get the perpendicular distance. Okay. Letter B. The smallest force applied at B that creates the same moment about D. Kung sodo ko na ang smallest force nga i-apply dire sa B na ang resulting moment niya sa D same sa letter A, no? Same moment D. Inanay hapon 41.7. So, pag smallest force gani dapat perpendicular siya sa distance paingon sa D. So, kuhaon mo ang distance from D to B. Kana. And then perpendicular na dayon, mo na yung force. Kana, perpendicular siya. Kana. Okay. Mo ni ang force nimo. Okay? Although dili siya di apo sa B, di force. So, kuhaon na nimo ni. 200 square to 200 may 200 sana siya. Kaya 200. So the distance from D to B is 200 square root of 2. So ang moment niya is force times distance. Kana. FB times kini. 200 millimeters man, convert na to meters, 0.2 na. 0.2 square root of 2. Tapos, equate din nato siya sa 41.7. And we can solve for FB. Mao na siya. Okay? Mao ni magnitude. Ang direction niya, 45 degrees because 45 man eh. 200 over 200, 45. So, ang direction sa FB, 45 degrees. Kana siya. Mao ni ang answer sa letter B. Smallest force niya. Nga ang moment niya, same effect sa A rin. 45 ba? 45, 90, so 45. Okay. Another one. An 8-pound force P is applied to a shift lever. Determine the moment of P about B when alpha is equal to 25 degrees. Okay. This is 8 pounds. And then ang atong alpha is 25 degrees. Okay. 25 degrees. Okay. Again, it is suggested na kining i-resolve nimo into horizontal and vertical components para dili ka maglisod pagkuha sa perpendicular distance. Imagine P inclined tapos magkuha kog perpendicular distance. Mao man na ang difficult part sa asahay kung mag-solve kag problem. So para dili ka maglisod, i-resolve mo into components, horizontal and vertical components. Para ang imong distances pod horizontal and vertical sad, di ba? Mas dali man mag-resolve aning force. So like this one. This is just 8 cosine 25. This one, 8 sine 25. 8 sine 25 is 3.38. Oh, dali ra, di ba? So kung mangita kag moment, oh, like this one. Anya ang perpendicular distance is kining vertical. No. Pila man ni? Oh, 22. Di ba? So, negative siya because dili mo ka rotate, di ba? So kung ma-form ko circle, clockwise siya, clockwise. Diba? Negative siya. Ang dalang imto kini 3.38. Ato ipadool para di ka maglibog. Mo din yung perpendicular distance. So this is 3.38, distance din niya 8 din. Negative also kay dili ka mo rotate, mo form ka og circle clockwise man na. So ang resulta maad ni sila clockwise din. Instead na mag negative, batawan niyo siya direksyon na clockwise. Okay. Mao ni ang answer. So instead na magkuha kag perpendicular distance, dili na lang. I-resolve into x and y components. Now, in the case of 3D, muna itong sample. The 6-meter boom EB has a fixed end A. Kini. A steel cable is stretched from the free end B, okay, of the boom to a point C located on the vertical wall. If the tension in the cable is 2.5 kilonewtons, determine the moment about A of the force exerted by the cable at B. Okay. So, ang tension na to is 2.5 kilonewtons. Dirgikan B to C. Recall sa ta. Muna itong force ba in vector form. Okay. Modern niya itong tension BC, B. 2.5. So, para makuha to ang X, Y, Z, move from B to C. Muna ito movement. Kana, bali, negative 6I. Wala tayo guide ha. Kabulan na mo. I ni J and then K. So, negative 6I. Kinama din positive. And then, move ka diya. That's negative 4K. And then you go up. That's positive 2.4J. So, muna imong distance BC. Negative 6I, positive 2.4J minus 4K. Muna imong distance 7.6. Imo nang substitute sa F. Na kay tension BC na 2.5 over D. There, negative 6, positive 2.4, negative 4. Muna imong component sa tension. Now, sa position vector dayon, gikan sa A, paingon sa B. Mo ni atong position vector R. Gikan sa point, kung asa ka magkuha og moment, paingon sa tail sa force. Now, unsa may distance ani? It's just 6I. Okay, along man siya sa along sa x-axis, 6I lang. And perform ka cross product, R cross F, kanara R cross F. So, I cross I, 0. I cross J, gamito nimo tong sign convention kanina, I cross J, positive K. And then I cross K is negative J man. Oh. Imagine I, J, K, I, J. My style, I, J, K, I, J. So, I cross J, I, J, K. Positive siya. Pero I cross K, Okay? I cross K na. I, J, K, I, J. So I, K, J siya, pero negative. But then the product of 6 and negative 1 is negative times negative J, positive siya. Okay? Okay. So mo na ang answer. Atong i-rearrange J o K din. Another one. Before the trunk of a large tree is felled, cables AB and BC are attached as shown. Okay. Knowing that the tensions in cables EB and BC are 555 newtons and 660 newtons respectively, determine the moment about O of the resultant force exerted on the tree by the cables at B. So you can solve this problem in two ways. One is, kuhaan mo og moment ang individual force and then i-add. That's one. Or ang isa is, kuhaan sa nimo og resultant ang duha ka forces, dayon R cross F dayon, which is mo ni ang nakasulat din. Determine the moment about of the resultant force. So first, kuhaan sa nato ang resultant sa duha ka tension, and then get the moment of the resultant dayon about sa O. Okay. So muna itong given, tension BA, 555, tension BC, 660. So delta BA, muna itong movement, down, and then move this way, and then diyan yan. So ang distance na to is this. Okay. Ang atong X is negative 0.75 I. Ang atong Y is negative 7. Ang K is positive 6. Mo na yan distance. Oh, and then substitute 555. Mo na yung component din. Next, BC. Move na siya down. Move this way. And then going to C. So, ang distance nimo, ang yang I is positive 4.25. Ang J is negative 7. Ang K niya is positive 1. Mo niya. Distance is 8.25. And then get the components. 660, this one, over 8.25 times XYZ. Mao ni siya. Okay? And i-add ni mo, kining BA, i-add ni mo ni, mo ni ang resultant. 340 minus 45 to 95, negative 560, negative 420, that's negative 980, 80 plus 360, 440. Mo ni itong resultant force. And then ang position vector dayon. Kana ROB, it's upward. Along sa y-axis, so ang R na to is just 7J. Positive 7J. Perform din ka. R cross, ang force na to is resultant. Ana, J cross J na po ng 0. J cross I is J cross I is negative K. J cross K is positive I. So J cross I, negative K is J cross K is positive I. And then rearrange mo na itong final answer. Same result you will get kung individual, no? R cross F plus R cross F. I-add ni mo, same result. Ana. So, that's it. Kung problem sa 3D, it's not that difficult kay kung master na ka sa distances, wala problema. Sa 2D, if the force is inclined, expect na ang imong perpendicular distance is inclined also. So, para dili ka maglisod diha, better na i-resolve nimo ang force into x and y components so that sure ta na ang iyang perpendicular distance it's either horizontal or vertical. So dili kayo lisod. Okay? Pero if you want challenge, you really want to solve for the perpendicular distance, there's no problem with that. Okay na. Okay? Anyway, the result is the same. Okay? Result is the same. So I hope that you have learned something. Thank you for watching.